When I was 8 years old, I went to Boston and took a tour of the USS Constitution. The Constitution is a heavy frigate of the U.S. Navy, launched in 1797, and is the world's oldest ship still afloat. She is known as Old Ironsides due to her ability to bounce cannonballs off her hull during the War of 1812. I recently saw a plastic model kit of Old Ironsides and noticed her jib sails are oblique triangles. I then wondered how much canvas it took to make one of the jib sails. The jib sails are the foremost sails used to increase the speed of the ship. I don't have access to the actual USS Constitution, but I was able to estimate the dimensions and scale it to actual size based on this lifelike model. Let's solve this question. What is the surface area of one of Old Ironside's jib sails? Let us begin with what we know. We know two side lengths, 4.1 inches and 2.2 inches. We know the included angle is 105 degrees, and we know the scale factor of the model is 1 to 196. The plan to solve this problem requires two steps. First, we need to scale up the model sail to life size. The next step is to use trigonometry to calculate the area of our sail, which is essentially an oblique triangle. Before we go further, let's estimate the solution. First, we need to scale up the model sail to life size. The model kit says the scale factor is 1 to 196, which means for every inch on the model, the real ship is 196 inches. We can accurately upscale the sail and trust the math because the triangles on the model and the real ship are similar. Since at the moment you are just estimating, let's round up the scale factor of 196 to 200, just to keep things simple. Then, let's round the two side lengths to 4 inches and 2 inches. Scaled up, the life-size sail is approximately 800 inches on the left side and 400 inches along the base, which when converted to feet is roughly 70 feet and 35 feet. Even though our triangle isn't quite 4 inches high, it is close, so let's ballpark our estimate using the formula for the area of a triangle. Area equals base times height divided by 2. So, now let's plug in the numbers. Area equals 70 times 35 divided by 2, which works out to 2,450 divided by 2. 2,450 divided by 2 is equal to 1,225 square feet. This seems like a realistic estimate, so our final answer should be close to this. Now, let's use trigonometry to get the exact answer. Again, we need to scale up the model sail to real life size. The scale model sail measures 4.1 inches, so 4.1 inches times 196 equals 803.6 inches. Let's divide 803.6 inches by 12 in order to calculate the length of the sail in feet. 803.6 inches divided by 12 equals 66.9 feet, which we will round to 67 feet. The base of the model sail measures 2.2 inches, so doing the same math, 2.2 inches times 196 equals 431.2 inches. Converted to feet, 431.2 inches divided by 12 equals 35.9 feet, which we will round to 36 feet. Now that we have the dimensions of the life-size sail, we will use trigonometry to solve for the surface area. When you know two side lengths of a triangle and measure of the included angle, you can use this formula to solve for the area of a triangle. Area is equal to 1/2 AB times the sine of C. Then, we can plug in the numbers, giving us the area is equal to 1/2 times 67 times 36 times the sine of 105 degrees. We will get area equals 1/2 times 2,412 times the sine of 105 degrees. After multiplying by the 1/2, we will get area is equal to 1,206 times the sine of 105 degrees. Once we put this into the calculator, we will get our final answer of area is equal to 1,164.907 square feet. So the final answer is the area of one of the USS Constitution's jib sails is 1,164.907 square feet, which for comparison is bigger than many Boston apartments.